So we've got a 6-meter ladder. It's up here against the wall. Now the bottom here, it says it's being pulled or pushed, just depending on where we are. We'll just maybe assume that it's being pulled, okay, for right now, at a constant 1/2 meter per second. So we're kind of pulling this out here like this. How fast is the top sliding when it reaches 5 meters up the wall? So when it's about 5 meters. When it's 3 meters, so when it's right about here, or when it's 1 meter, right there. Now, just to be clear, this ladder is not in free fall, okay? It's not like, falling totally unsupported. It is supported. There's a person holding it and moving this down, and so the rate at which this is falling depends on the rate that we're pulling it out. And you might think, oh, it's being pulled out at 1/2 meters per second, then that means this is going to be sliding down at 1/2 meters per second. That might be a naive first glance sort of look. We saw earlier that it is not, right? We saw that as you pull this down, and this is just going to constant rate, that top rate changes. So there's some non-intuitive aspects of this, okay? So this problem is asking how fast is the ladder top sliding. So it's asking you about a rate, okay? These type of problems are called related rates because it's asking about this rate and we've got another rate and we have this sort of picture going on here. There's sort of a go-to way of setting these type of problems up, okay? And that's one of the things that you need to have memorized for tomorrow. And I always just kind of write it across the top here. Formula, given rate, find, and when. If you organize your problem in this manner, then it'll help you kind of get a grasp for what's going on, help you give you a common workflow. All right, dealing with the formula, we also normally have to draw sort of a base picture representing the geometry of what's going on here. So I'll just draw a generic right triangle here, trying to use the same values there. We've got y for the vertical leg, x for the horizontal leg, and we're told that this is always equal to 6. Okay? With that sort of situation, what formula or formulas come to mind? Pythagorean theorem, okay. So a good formula would be x squared plus y squared equals 6 squared. I'll just write 36. It could be that maybe we need to use some sines and cosines and stuff like that, but we're really not given any angles, okay? Normally in these type of problems, there's going to be a given rate. Now it says pulled or pushed because I wanted to because the animation here shows pulling and pushing. Let's just assume it's being pulled, okay? So what does this mean? That the ladder is being pulled at a constant 1/2 meters per second. I'll write it in a sentence. So the ladder bottom is pulled at a rate of 1/2 meter per second.
dx becomes greater.
X is becoming greater. I like what you're saying about dx. So you're saying that the rate of change of x with respect to time is
a half.
Yeah. 1/2 to the meter per second? Yeah. What we did yesterday when we were taking verbal expressions and turning them into calculus expressions is why we did that is for this very part. To turn that sentence into calculus notation here. dx over dt is 1/2 meters per second. So that's good. Now, find. What are they asking us to find? The question says, how fast is the ladder top sliding down when it reaches 5 meters, 3 meters, 1 meter up the wall? Well, it actually says when. So, I mean, our when is when y equals 5, when y equals 3, and when y equals 1. But in words over there, it says how fast the ladder top is sliding. How could we put that in calculus notation? The rate of change of y, so
dy over
Yeah.
dt.
dy over dt. To put this in further calculus notation, we could say find dy over dt evaluated when y equals 5. Or dy over dt evaluated when y equals 3. dy over dt evaluated when y equals 1. That's what we're going to figure out here at the very end. Okay. Well, I have dx over dt. I'm trying to find dy over dt, but I don't have any equations that tell me how this rate relates to this rate. I just have a formula with how x relates to y. But if we take the derivative of this with respect to time, then we will have a way of relating those two concepts. So after I kind of have all of that stuff taken care of, my next step is to kind of revisit the formula and take the derivative, I'm annotating here, with respect to time. Which, if you recall, that was the other activity that we did yesterday, and would be wrapped up for homework. So, we've been doing that so well, let's take the derivative. Now, we're remembering that x is really a function of time, and y is really a function of time. So when I take the derivative of x squared, it's going to be 2x times dx over dt, applying the chain rule there, plus 2y dy over dt equals 0. Okay? Now, inevitably, I'm looking for dy over dt. So what I might do is I might manipulate this and isolate the dy over dt. So we could probably do that maybe all in one step. So dy over dt equals subtract 2x dx from both sides. So it's going to give me negative 2x dx over dt. And then, yeah, divided by 2y. Now the 2's cancel. And dx over dt is 1/2 meters per second, so I can plug that in. So I have negative x times 1/2 meters per second divided by y. Or if we wanted to write that as negative x over 2y. Kids, think of it think of the numerator. X times 1/2 is negative x over 2 times the reciprocal denominator, 1 over y. So that's negative x over 2y. Look good, Rigel?
Yes, sir.
So that's a nice expression for dy over dt.
And now can you just insert the 5?
I can insert the 5. So evaluating when y equals 5, I'm going to have negative, well, hold on, what's the x going to be? I can plug in y, I can say 2 times 5, but I need to figure out what x is when y is 5. Does that make
You
sense?
can just put 5 back into the fragment here.
I can, yes. Where I've got 6 right here, 5 right here. 36 minus 25. 11, so square root of 11. So square root of 11 over 2 times 5, so 10. Go ahead and give me a decimal answer on that. Grab a calculator, don't have one?
That's 133.
Say it again?
133.
133? What are the units gonna be on that? What should they be?
Meters per second.
Meters per second. That's how fast the ladder, the top of the ladder height is changing at, when the ladder is, top is 5 meters above the ground. What does the negative mean?
But it's like on the negative direction.
Close. Or what I would say is that y is decreasing. Okay, let's find dy over dt when y is equal to 3. So using our formula, it's negative x over 2y. So what I need to do is, I have a negative up there. The x value I'm going to need to once again sort of calculate by hand. I have 3 here and 6